Right, so in this video here we are doing a guided practice for the square roots basic video, ways to write it. So if you haven't watched that, make sure you watch that video. I did copy down some of the key components from it that at least we're going to be using for this guided practice. So what we have up here is the different ways to be able to write the same exact exponents or radicals. So whether the m is here and then you have your fraction as an exponent, etc., these all mean the same thing, and we're going to be showing about how you can use them when we apply them. So let's go ahead and look at a to the 5/3. So we have what's called a rational exponent. It's put in as basically a ratio, which is another way of saying a fraction. So we're going to be looking at trying to write it this way. And as you know, when we multiply a power, or basically raise a power to a power, then we end up multiplying these exponents together. And we do m times 1, which is m, and well, any whole number over 1 times n would give us this number here. So we're just working our rules of fractions. So I can rewrite this as a to the, here's my numerator, my n, there's my m. So 1/3, raised to the 5th, because 5 is my m, which means I can also rewrite it as a to the 5th, because again, I could do 5 over 1 raised to the 1/3. Because if I multiply these together, I would still get 5/3. Now this starts becoming the transitional part of how you can switch between a rational exponent to an actual radical using the root symbol. Now the denominator means the process of getting smaller. So does the radical. So that means I'm going to take my, what would be my n, and put it here, and it becomes a cube root of a. And well, my exponent is the process of getting larger, just like my numerator, and so that would go out there. So again, we're looking at different ways of writing the same thing, whether it's 4/4 gives you $1, whether it's 10 dimes give you $1. These are just different ways of making up the same quantity. I haven't changed my value, I'm just rewriting it. And so last but not least, this would be my 3 and 5. So the important thing to notice is that this here and this here are two ways of writing, again, the exact same thing. So with the guided practice, let's go ahead and put down another example, a to the 7/4. So this time I want you to go ahead, and we're going to pause the video, and I want you to write down the 4 other ways to be able to write this same rational exponent. So go ahead and pause the video now. On your own. That's a significant part about guided practice, is for you to be able to practice and check your work and see if you're doing it correctly. So let's go ahead and see what you should have put down as our different ways of doing this, and hopefully you have something that looks like these. And if you do so, awesome. If you don't, then maybe we can try another number and try it again. So again, an important part from this here that's going to play into is note that a to the 7/4 is the same thing as 4 to the a/7. And you can use these as notes. So it is important to be able to write these down, because everything you write down not only increases retention, but also makes it so you can refer back to these later if need be. So with this, the reason why that's important is because you also want to notice that I can rewrite this same exact concept this way. Radical the fourth root of a to the seventh is the same thing as a to the 7 4. It doesn't matter which direction you're doing it. You can rewrite them either way. Now, if I look at my 7 fourths, I can start applying the rules of fractions to them, which says that a to the 4 fourths times a to the 3 fourths is the same thing as a to the 7 fourths. Because when I multiply like bases, I add my exponents. What that also means is that I have a to the 1, because 4 divided by 4 is 1. And I can actually rewrite this, as we already noted up here, as fourth root a to the third. And I've now officially simplified this original a to the 7 fourths as a to the 1 times 4, the fourth radical of a to the third. And that's what we're looking at. We're creating our 1 wholes. If I have 4 quarters, I have $1 and 3 out of 4 quarters left, if I have 7 quarters. So let's apply this again to another one. If I have cube root of a to the 10th, go ahead and take a second, and I want you to write this first as a fraction, like we have up here, and then I want you to try to identify how many whole numbers you can pull out of this with how many left over, and see what you can do. So apply this up here to this one. So go ahead and pause it now. Okay, so hopefully you have completed it. And what we're going to be looking at is, first we're going to write this as a fraction or a rational exponent, identifying my m and my n. And then we're going to start breaking this into whole numbers. So 3/3 is 1 whole, 3/3 is 1 whole, 3/3 is 1 whole, and then we have 1/3. And 3, 6, 9, 10 thirds is what these equal. So it's the same quantity, just identifying each of my 1 whole fractions. Going from an improper fraction to a mixed fraction is what we're trying to do. So what that means is that's actually just this: a to the 1 times a to the 1 times a to the 1 times, well, a to the 1/3. And that means we're going to add our exponents together and thus get a to the 3rd cube root a to the 1, because, well, there's 1/3 left over. So initially the question was 10 divided by 3. It goes in 3 times with 1 left over. And if you kind of start making that connection, then these start becoming faster to do. So let's look at another example. So let's say I have the cube root of a to the 14th. So try to go as close from here to here as possible. And pause the video and do this one on your own, and then we'll resume and check our work. So fraction, improper fraction, to our radicals where you want to try. If not, go through all the steps as needed. Okay, so the first thing that you want to do is write it as a rational exponent with your m and your n. So hopefully you wrote it to look like that. And then we have our classic, well, again, improper fraction to a mix goes 14 divided by 3. How many times does 3 go into 14 evenly? And then with how many left over? So it goes into evenly 4 times, which gives us 12. And then that's going to leave us with 2/3 left over, or 2 out of the 3 that I need to make a whole number. And thus, that is my simplified version. Okay. So that is how you can go about to take these and simplify them. And it doesn't matter if it's a 3 out here or any other number. if I have 5 and then a to the 13th in here, well, you can pause the video and try it on your own. And we're going to get the same thing, 13 divided by 5 basically, which means it goes in 2 whole times. We're taking the 5th root, and I'm going to have 3 left over. And so that is my simplified answer. So that's how you do those. So the other important part to kind of remember is just this, is that it doesn't matter what this irrational number is, this index is, that anytime I have something that looks like that, it's going to give me a to the 7 over 7, which is just a to the 1. And etc., etc. All right. I hope this video helped.